In this course, we're going to lean heavily on theories, models, and taxonomies. What are they? How are they different? What good are they? Let's begin with theories. Hoover, in the Elements of Social Science Thinking, defines a theory as a set of related propositions that attempts to explain, and sometimes to predict, a set of events. This doesn't mean we pull the theory from thin air, but rather it is plausible explanation of a phenomena based upon observed events. Let's walk through a simple illustration. Here we have an unknown process. When we take an input, the red rectangle, and subject it to the process, the output is a green rectangle. What might be happening in that process? Based on the scant evidence, one observation, what are plausible hypotheses? Perhaps the process paints the input green. That seems to fit. It is our working theory. Let's test it with another observation. This time the input is a blue rectangle. We predict the blue rectangle will be painted green. The output is a green rectangle, so the theory is still confirmed. We predicted the output would be a green rectangle, and it was. Let's test it again. If the input is a blue circle, what do we think the output will be? Well, a green circle, of course. In goes the circle, and out comes a green rectangle. What does that do to our theory? It disconfirms it. Based on the observed data, it can't be right. So, what is happening in the unknown process? How about this? The process takes any colored shape and transforms it into a green rectangle. Does that align with the observed data? It does, and the theory appears to be valid based on our limited data. And so it goes. Theories can never be proven right because the next observation might disprove it, but they can be proven wrong by disconfirming data. Now, obviously, we would have more confidence in a theory that was confirmed by 1,000 observations rather than 3, but you get the point. So, let's recap. Theories help us to explain why events happen, predict the future, analyze alternatives before choosing one, and lastly, act in a non-random fashion. Another tool useful to aid analysis are models. A model is a simplified description of a system to assist calculations and predictions, according to the Oxford University Press. Here are examples of models that help show interrelationships or complex concepts. Let's summarize. Models help simplify complex things, provide a method to articulate the interrelationships and interactions between parts of a system, and help us to focus on cause-effect relationships. The last tool I wanted to talk about are taxonomies and typologies. These are ways of classifying or sorting things or events according to a set of observable criteria. For example, the Bloom's taxonomy or biological taxonomies. Taxonomies and typologies allow us to group or separate events, systems, according to a systemic method. Application of a criteria forces analysis of the things being sorted, and they provide a rational basis for applying different treatments to different systems. As we work through this course, we will use theories, models, and taxonomies to provide an orderly framework for analysis. A few cautions are in order, however. Remember that they can oversimplify, especially when dealing with many variables. They all have limitations. More than one can be useful. And lastly, these can be refined with more data.